Okay, hey everyone. I'm Matt. I am DevRel, focused on EigenDA at EigenLayer. Also just broadly. So I'm going to talk about verifiable services and try to apply it to agents, AI for this hackathon. And ideally you have the tools and understanding to be able to build something here. I'll be around throughout the hackathon as well. Feel free to reach out. But the purpose of this is broadly introduce it. If there's anything that is unclear, hopefully it's not. Just throughout the workshop, feel free to just stop. I'll leave time for Q&A at the end. But yeah, we can get into it. So yeah, just titled this Verifiable Services on EigenLayer. It's kind of what we do. Thank you. All right, so we'll run through quickly just an example, roughly talk on agents, as that's a tangible thing that people can feel with AI or agents broadly. What is EigenLayer and AVS? How? Demo, Q&A. Also touch on hackathon, just some of the logistics there. All right, we'll just get right into it. So broadly, given the context of this hackathon is focused on AI applications and agents, what is an agent itself? It's kind of composed of three large aspects. You have largely orchestration. This is the goals, the intention of an actual agent, the memory, short-term, long-term, as well as some model-based reasoning or planning. And you have the underlying model. These are the OpenAIs of the world, or Claudes, or DeepSeek. And then you have tool calls. And that's kind of what makes agent unique, is that now it has the ability to reason and then outsource some sort of execution to another tool and get back to the response so that it can try to achieve its task. And I'll just pose the first question, which is essentially, how do you ensure that the agent does the correct thing? Well, the reason why you'd want to ensure that it does the correct thing is that there's potential downside for the wrong thing happening. And maybe an example of this was Phrasa, which was essentially an example of showing what would happen if you were to try to jailbreak a agent. What that means is that Phrasa had funds that it was holding and responsible for. And the whole game was essentially, I want to be able to try to jailbreak it. I'll prompt it, trick it, so that it will send me the money that it has. So there are over 400 attempts and ended up transferring over $47,000. That was the intention of this. But if we were to have agents or any AI system that is managing funds, it's very important to have some guardrails in place to ensure that the funds that it's given custody over are safe. And how do you sort of ensure that? Broadly wrap that around this term of verifiability. There's two sides to it. There's the intention of what you want to happen, and then the actual execution. And I'm broadly wrapping both of those under just verifiability. So the idea is that if you can have all of the stack essentially verifiable from the memory, right? So what it's working off of, its working memory, you can ensure that there's no hallucinations. The model itself can actually be created in a way that ensures and aligns it with the proper intentions. And the tool calls. You're only as strong as your weakest link. And if any of the tool calls were to be potentially have any injections into them, or any incorrect responses that were to happen as a part of any part of the execution, that can then compromise your system. And we're building, hopefully, systems that are going to be strong and can run on their own with strong guarantees that they are doing the correct thing. So if we wanted to build a verifiable agent, maybe the first thought is that you want to just build it as a smart contract. Smart contract is programmable. When I write the thing, it should do what it said. And that's kind of underlying that is, let's say if you're using Ethereum or a proof of stake system under the hood, it's all of the underlying infrastructure essentially ensures that when you expect that your code to get executed as you wrote it, it just does. And that's kind of one of the guarantees that you get when you're working on top of a blockchain with smart contracts. Well, sweet. If we were to do that, what would it look like? This is an example if you were to try to have a booking agent, essentially for travel. That's one of the examples that people like to touch on around agents broadly. And you have a user that sends some prompt to some smart contract. The smart contract orchestrator will kind of do a couple key things, maybe try to search for a flight, do the booking, do a hotel search, do the hotel booking. Underlying that's all the reasoning and model of the actual agent that's doing all of the reasoning of like what is the best rate, what is fitting with the intentions of the user. And quite frankly, that just doesn't work on chain. It's too computationally expensive. It's also likely using the incorrect tool for purpose. There's maybe some part of this that makes sense to have potentially like payments and ensuring that agents are doing the correct execution on the payment side, but not everything has to be on chain. I think that's just broadly the point here, is that not everything can or should be a smart contract. It's either computationally too expensive and you can't write the logic that you write. And that's the truth for things today. In Web 2 applications, you have not just, if you're building an e-commerce application, it's not just payments. You aren't just sending money to someone. You're also doing potentially fraud detection, inventory management, rewards, and essentially this whole like software as a service stack that allows you to build a full stack application. And verifiable services create, extend, and enable end-to-end full stack applications. So I was talking that there is an alternative. What would that alternative roughly look like if I were to have, using the Freza example from before, what's the interactions that people are broadly doing is that there's users who are providing prompts trying to jailbreak it. There's actually like a relatively simple fix to this, and that is that you can have sort of like a policy, we term these AVSs, I'll touch on that later, just a policy service, essentially checking certain criteria. Is it potentially trying to jailbreak or hack or withdraw funds from the system that this agent has access to? Like, yes, stop that and don't let that happen. No, let it happen as usual. So essentially what you're starting to add on is better guarantees that the agent is doing the thing that you would like to do. And then I'll like lightly introduce this concept as well of just like zk-TLS. Out of curiosity, has anyone here heard the term zk-TLS broadly? All right, perfect. Okay, zk-TLS is just a concept. It allows you to verify Web 2 data. And what that now means is that you can verify like Web 2 data, prove it. So the basic example is, let's see if I use it here. Basic example is that I want to prove how much money is in my bank account without revealing that. So you have your bank balance on some service that's not going to be a blockchain, most likely right now. You have existing Web 2 services and you want to be able to prove that. Essentially, zk-TLS allows you to prove any Web 2 data, and now you can start to like export that data and use it in other applications. Super high level. I'm happy to talk more about that after. But this was an example, essentially, is how do you ensure that your model is actually coming from OpenAI in this case. And what they actually, there's a couple teams that are building zk-TLS on EigenLayer. They allow you to like sort of stamp and ensure that the API request that you received is actually coming back from OpenAI and not random data server that is down the street. So that's like broadly some of the flows that it might look like. And I'll just introduce broadly EigenLayer. It's the verifiable cloud. And ideally for developers here, what that actually means is it's the simplest way to use or to build verifiable services. And lightly touching on verifiability, underlying that is like customizable crypto economics, cryptographic signatures. So I'll quickly go through this. Let's see. So if you were to have like open innovation, which is like broadly a concept that we think like blockchains enable, you had like Bitcoin, which was like full stack essentially. It was the application, which is like being able to send money to anyone, anywhere in the world. There's the execution of that. There's the consensus and security that's all baked into one thing. And Ethereum had this idea, what if you were able to actually make any application underlying is still the same platform, but any application can be built on top. So we've seen things from like DeFi to social be built on top. And then we move to this point where, okay, it doesn't make sense that everything has to execute in the same environment. It's too expensive, and you need to expand, essentially like horizontally scale. So now you have roll-ups where there's different execution layers that then settle to Ethereum, and you have applications built on top. And what EigenLayer allows you to do is it goes even one further step, where now anyone can build these consensus layers, these verifiable services. On top, you have any additional execution layer, and really this is meant to just serve applications, agents, AI, whatever the end user is. It's essentially allowing you to build full stack applications. So the structure of this is, I'll go into this. If anyone wants more details, I can go into it after. Essentially brings together stake. So if you heard the term restaking, so economic capital, it brings compute, people that can actually run services. So if you're writing a service, there's some computer out there that actually needs to run that code, your Docker image, and it brings those two together. And then you're able to build or use an AVS. So broadly term that AVS developers, apps, agents, etc., can be consumers of AVSs. These are broadly just making API calls. All right, so quickly, I'll touch on this and then go into maybe actually what I'm talking about. EigenLayer, we have 2 tracks. It's like best new AI AVS, first and second place, 1500, 500. Best AI application or agent built using an existing AVS. It's 1500 or 500, and I can go into some of the details underlying this. So like really broadly, I glanced over maybe how EigenLayer works. I'm happy to spend time on that, but what's kind of like being built within the ecosystem. So broadly I'd split it up between like roll-up services, code processors, cryptography, proofs, and other. This was created in 2023 when EigenLayer was like first going to mainnet and actually like being enabled. And this was the hopes essentially of different things that we were wanting to be built. So like blockchain-wise, decentralized sequencer, bridges, to anything to like AI inference or ZK provers or oracles. And now there are actually teams that are working on top of this. There's over like 80 plus teams that are at various stages building on top of EigenLayer with over 60 on mainnet today. And then more applicable, like broadly, for this audience, the AI AVS categories. So the idea is that for AI or agents or any of these services to actually get like executed and execute with like strong guarantees, you're going to need multiple services to be able to build that out. There's data services, model deployment, model development, agent tool calls. So broadly, these are different categories of services that we expect or are currently being built out on top of EigenLayer right now. And what is an AVS? Essentially, it's just any like permissionless system. What that means is that you can write Rust, Go, TypeScript, anything that you can package essentially as a Docker image, and then distribute to operators of the network. They'll essentially sign up and start running your service, and you can create like customizable crypto economics essentially to incentivize proper behavior or essentially disincentivize incorrect behavior. So there's a combination of on and off-chain components. And like what this might look like is that if you're building something on blockchain, if you have any sort of smart contracts, you can just have an on-chain task creation and operators then pick it up, execute. Or you can have even like off-chain task creation. The architecture of AWS is like very unopinionated and up to you to be able to decide. So the product I focus on is EigenDA, which is a hyper-scalable data availability. And like the tasks are actually just created off-chain and then sent to operators of the network. All right, I'll pause there. That was a lot of me talking. First, if there's any questions, I can answer them real quick. Or if not, we can go into like the hello world, essentially, of EigenLayer. All right, sweet. We will just get into the example. If you want, you can check out this. If you scan this QR code here, you can actually go to the repo and go to the incredible squaring repo. And broadly, this is like what we'll walk through, like the service. I'll give a minute. Let's see. Okay. All right. So real quick, I'll just like, before we actually like run anything, I will just tell you what this essentially is. So here's all of the instructions, GitHub repo for it. It's like relatively trivial. Essentially, the idea is how do I make sure that these numbers are getting squared correctly? So what's essentially going to happen is that we're going to have a task. That task, this is like what you would essentially define on your smart contract or your code, the number to be squared, and then it gets executed off-chain, and then anyone can validate and ensure that that like happened correctly. I can kind of just run through quickly the steps that we have here. So let's see. All right, I'm going to just start Anvil here. I've already done some of like the prerequisites. Deploy the contracts. Essentially, there's smart contracts on Ethereum. This is like any stake, any like capital essentially that's been like allocated to EigenLayer that then can be leveraged by these AVSs, as well as like the operators that have registered to the network. So the operators are the ones that are actually going to be running your code, and this like essentially keeps track. You have the operator state on chain. They can execute things off chain, and you can check those off or on chain as well. So I just started. Did I just start the? Let me check. All right, we're gonna start the aggregator real quick. I think here. This is essentially the one that's gonna be sending out the tasks. All it's literally doing is like creating the task. It's creating the number to be squared, and then we're gonna create the operator, and this is gonna be the one that's actually executing the logic. Essentially what this is doing is like, in a similar way, if you're to have like Ethereum, where there is the code that's the Ethereum protocol that's being executed, like geth or ref. Similarly, you can do the same thing, where now, I think we're running into an error on that. That's perfect. Not sure exactly what's happening on that right now, but essentially like the basic idea is that if you have something, it can either start on-chain, start off-chain, get executed by these operators, and anyone can validate and ensure that that's happening correctly. So like really broadly, there's a couple ways that you can actually just build an AVS. Like there's the actual just protocol logic, and the most customizable way that you could interact with that is using our like Go or Rust SDKs. Here are our docs here. I'll include a QR at the end. There's also like teams that have built abstractions on top of EigenLayer to be able to get you started a little bit quicker. So Authentic has like a TypeScript SDK that's really easy to get up and running. Essentially, what you can do is essentially you're defining like two parts of your logic. You essentially define, it's like what is the task that you want people to do, and then how do you actually validate that? So that's a pretty straightforward way to get started. There's also Layer. There's a really good example that they put out recently, which is just building an oracle. It takes you like 10 minutes to build an oracle in Rust, and it's a WASI runtime, so they have a Rust SDK. So if you check out Layer right here, this also is like a really quick way to essentially build a service. So I think, let me see if I can show you real quick. Yeah, so I think like these are probably the simplest ways, especially for this hackathon, to get started is like one of these paths. And yeah, I guess the quick recap is like we're gonna need some sort of like verifiability for working with any of these, like this AI broadly, whether it's like agents or else. And an AVS itself is a combination of on and off-chain components, and you can build using EigenLayer SDKs or frameworks like Authentic Layer. So if you were to take one picture, do one thing after this, just this slide essentially would be the most relevant. This is our quick start. It will essentially allow you, it would just get you up to speed. It's the best place to understand what EigenLayer is, get started, and we included any links that hopefully should be relevant. And yeah, so I'll be here throughout the hackathon. Feel free to message me or just talk to me here. Yeah, I'll take any questions that you might have.